I will try to keep this fast since I imagine there are plenty of people who are pretty hungry right now, including myself. So this is our many monsters. So to start off, maybe I won't use this. To start off, who am I? So my name is Megan. I'm currently an engineer at Slack, and I'm an engineer on our operations team, more specifically our visibility operations team. And I'll explain what that means later since, as someone mentioned earlier, what the hell visibility means different things at every single place. I've been at Slack for just over 2 years now. If you want to find me on Twitter, I'm Megsa _. The underscore is important. Someone stole just plain Megsa, so I'm Megsa _. But most of my tweets are really boring, so don't worry about it if you don't look. So what is this talk going to be about? I want to talk first about what this talk is not going to be. This is definitely not a how-to. This is not even a recommendation. And it's not going to be the best way to use tool X because the way that we use particular tools is probably going to be very different from how it works for you. This is basically what we've done at Slack, why we've done it, some things that we've learned while we've been building out these different systems, and hopefully it'll help some of you, you'll be able to find sort of comrades in arms for some of these tools. I also want to add the caveat that if you're using a vendored solution, this might not help you much, but hopefully it'll be interesting to some extent. So our agenda for today. First, why? Why anything? After that, we'll get on to each of the tools, or each of the systems that we have and the tools that we're using to build those out. In particular, metrics, logging, and alerting. Why are we using open source tools? And all of the tools that I'll be talking about today are open source tools. I want to start off and say that vendor solutions are actually pretty awesome. This is not a talk to shit on vendors. They are fantastic. They are a little expensive, and I'll explain some more on that later. Personally, I think that if you can afford them, vendored solutions make a lot of sense. It makes sense to pay a team of people whose entire job is building good business-grade monitoring software. Those of us who work in companies, we have other obligations. They are able to take the time to put in a lot of work to give you a really good product. You kind of have to evaluate trade-offs and figure out if they make sense for you. It didn't for us, it might for you, and if it does, definitely look into vendors. That said, for us, with the scale of the things that we are monitoring right now, our yearly cost would be extremely high. I'm going to go into specific details on this later. I'll kind of anonymize some of the vendors to be polite. But basically, with a lot of the well-known solutions, we would be burning absurd amounts of cash. Unlike Brian, I don't work somewhere that practically mints money, so we have to be a little bit more frugal in how we choose what we're using. An alternate title for this talk, I've realized as I've been going through it, is basically technical things Slack has done to save us a crap ton of money. So one of the other reasons is that we also don't have enough people right now to build our own awesome in-house solutions. There are a bunch of teams doing really cool things at Twitter and at Facebook where they're building out things like Gorilla and Barenge, and those are cool, but we are a pretty small team of people. We've ranged at times from about 1 to 5 full-time engineers for our visibility operations team. What that team is, we are responsible for running and presenting metrics, logging, alerting. We're also responsible for a bunch of data warehouse infrastructure, and we also have our usual ops and on-call duties in addition to all of that. So when we're looking for solutions, we're looking for things that are well-documented, that have large communities, basically things where we can draw on the knowledge of people who came before us and who are able to help us out if we have questions. Eventually, we'll go off and test things on our own, but for now, we're going to stick to what is known to work. So why the particular tools that I'm about to talk about? I really wish I could say that we had started, we'd tested all of these things intensely and that we'd done really good bake-offs and we'd analyzed the pros and the cons. But the fact of the matter is we're human, we're all human. How many of you have used something here because you used it at your last place and you're like, I know this tool. Don't be ashamed. We can all be ashamed together. Pick your, in any case, what we did is we used a lot of tools that we had either used at old companies or that we were familiar with and decided to grow from there. In some cases, that's actually worked out pretty well for us because having that knowledge in advance was helpful. In other cases, the old knowledge and tools haven't really meshed entirely with the form that they've taken at our company now. So I'm going to dive deeper in a few particular cases. So let's start off with metrics. So some stats, and I will be showing some diagrams later for each of these things. We're using a kind of modified graphite stack for background. So we currently store up to 30 days of data, and we found that to be sufficient for most of our common debugging and investigation use. There is, as mentioned earlier, an additional data warehouse where we store logs and metrics for much longer, and you can perform all sorts of like intense analysis and queries on those. That's an entirely different talk. We have a data team, they are awesome. This is gonna focus specifically on the things that we use for as a base kind of for alerting and as well as debugging or looking for perf improvements, that sort of thing. We have 160 hosts, and really it's about 80 hosts worth of unique data with a replication factor of 2. Some of our metrics serve as the base, as I mentioned, for alerts, and we value high availability here because of this. So given the long time to restore from a backup for each of our hosts, we basically want to be able to swap a new one in as soon as possible if something goes down. We currently store 90 terabytes of data for those 30 days, and we persist about 1.5 million metrics per second to disk on the graphite side of things. So before we get into the details of what we've built, let's go through some anonymized pricing schemes. I apologize to all of the vendors that are here in advance. So first up, a vendor that charges per host. There's a couple different people that do this sort of thing. They range in price. Some of them charge you per host, but they have limitations, such as a couple hundred unique metrics per host. For us, we have some hosts that do on the order of thousands of unique custom metrics. So there's already restrictions in place that don't allow us to use them. Other ones, they scale based on the type of host that you're using in Amazon. And I think that the listed cost, and I'll get into the list versus actual cost in a second, the listed cost goes up to like $200 for a particular host because it's just that much more intense. That doesn't really work well for us. Another common pricing scheme that you see is we get charged per metric that you store at a particular resolution. We store at a 10-second resolution, so for one particular vendor, it would cost us 25 cents per unique metric stored at a 10-second resolution. And the best one I could find was about 10 cents per metric that we'd store at a 10-second resolution. So for us, total unique metrics we send, not including aggregations. Aggregations are something separate, but basically things that get sent to our relays. We have about 9 million unique metrics. If you multiply that by 10 seconds per metric, and you get 50% off because it's not enterprise software if you're not having to haggle for what you're paying for. In our best case scenario here, we are paying $450,000, this is per month, with our current setup. And I don't know about you, but that's a bit expensive. Maybe not for Brian, wherever you are. Good job. I wish I were you. But for the rest of us who still live in startup land, it's a bit expensive. And it's for something that we have very little control over, and that's going to increase linearly as we increase our metrics, which is something that is pretty much guaranteed for us. We could try to do all sorts of tricks to try to save at a lower resolution to basically make it a little bit cheaper, but that doesn't really help. So let's take a look at what we built instead. Let's see if I can get this to point. Yes. Okay. So to start off, we have clients. Basically, our clients send metrics using Collectee, StatSite, and a bunch of other agents, sometimes just directly to the Graphite agent itself. That goes through an ELB, which goes to our Graphite relays. Another thing I didn't put in this is that there's an additional set of relays that are doing aggregations. Those are kind of specific to us, and it's not like I'm trying to hide them from you all. It's just that we could go pretty deep in the weeds of the weird side project we're doing there. The important thing to note, if you're using multiple relays, you need to make sure that your metrics are consistently separated and sent to the same relay for aggregation. If you have your relays separate from your storage layer, basically what happens is you have metrics going to multiple places, you're going to end up with competing aggregations trying to go to the same storage location, and your aggregations are just going to be completely bunk. But yeah, those live off on the side. Basically, they go to these relays, which go to Graphite Carbon. I'm going to zoom in a second. On the front end side of things, we have Grafana for visualization. That queries Graphite API, we call it Graphite API is the host name that we use. And that also goes down to the Graphite Carbon boxes. So originally, we started off with pretty out-of-the-box things for our relays and for the Graphite web, which is now the Graphite API components. On the client receiving side, we've switched to using Carbon C Relay. This is an enhanced C implementation of Carbon Relay, and we found it to be a lot faster for what we're doing, and it provides some pretty good aggregations. This is zoomed in view, so we're going from here to here. Cool. On the Carbon hosts themselves, we've replaced a number of things. We've replaced Carbon Relay and Carbon Cache with GoCarbon. Again, that's kind of in the name, it's Go-based. It's a lot faster, and it maintains a write-through cache, which helps us when we're doing queries over here. And then on the, basically what is normally Graphite Web, we call it now Graphite API. We replaced everything with Carbon API and Carbon Zipper. These are, again, Go-based, and they, again, give us a lot of speed benefits. Given the size of our cluster and the number of metrics we have, basically all of the tweaks that we make are trying to make query performance as fast as possible for all of our users. There's other things we've done to try to sort of improve the user experience. So on the front end, we've added a couple things to Grafana by hacking into the code that the folks at BrainTank made, and also using custom dashboards. If you're not using custom dashboards, I highly, highly, highly recommend it. They can do pretty awesome things. So these three things right here are things that we added in ourselves. These are not things that you get with Grafana. The first one, while we try to think of things at sort of a higher level herd view, occasionally there's someone who wants to see every single metric for this one particular host. And this is kind of a hangover from our old Ganglia days. And if you want to like see me cry, like talk to me about Ganglia after this. TLDR, it's stuck in 1997 and it makes me want to vomit. But yeah, so basically what we've done is we have built a custom dashboard, and we've built a page that sits on top of that where you can put in the name of the host that you want to see, and it will just spit out graphs for all of the things for that particular host. Another thing we've done is this explore feature. People don't necessarily know where to find their metrics. Since we're using Graphite, there's this namespace of doom, which is kind of horrific. We want to make it easier for them to find their metric as soon as possible, so we just built in a little search feature. Under the hood, we're kind of aggregating and indexing all of the metrics that exist ourselves and storing those on the Grafana host so that they can query them, as opposed to fanning out that query to all of the Carbon boxes and saying, like, tell me every metric that exists. We just do that in advance for them. And then finally, the ad hoc graph feature. If you're not familiar with Grafana or you're using it for the first time, like understanding how to make a graph, you're just like, you come in, you're like, I have this metric I want to see, and then it's like, how do I see it? We just kind of like stripped out that whole thing where you have to like go to make a new dashboard and then click like the graph panel. Like it's just like, here's a panel, put in your metric. And again, all of these things are basically to make it as fast as possible for people to answer any questions that they might have. So what are some of the lessons we've learned for this particular system? There's a lot more than here, but here's some of the key takeaways. The first one, tagging. This is Graphite specific. Not having tags is pretty hard, and your workarounds get to be pretty messy as you try to extract things from that static Graphite namespace of doom. Dot delimiting really sucks. It's like not intuitive. Metric metadata, like metrics 2.0, and the idea of metadata with your metrics is like the future. Just get on the bandwagon if you're not on it already. Aggregations. If you can aggregate it, people will want to aggregate it. We're going to have some audience participation here. I want you all to repeat something with me. You cannot aggregate percentiles. All together now. No, I mean it. Come on. 1, 2, 3. You cannot aggregate percentiles. Sorry. Well, actually, you can, but you should not. Basically, there's a fun secret. People will want you to make these aggregations even when the resulting data is complete and utter garbage. And even if you tell them this data is garbage, they'll still be like, this data looks great. And you're like, nah, it's jank. There's nothing in there that is real or honest. So yeah, aggregations. Be aware of what you're doing. Make sure your users know what you're doing when you're aggregating things, and make sure they understand what they're asking for when they want to aggregate things. And finally, forking things. Sometimes, like we've done with Grafana, we'll fork something for a very particular use case for us. As mentioned earlier, there's that host name or the host view. That's pretty particular to us. Sorry, Mike. You don't always need to try to push it back upstream. And if you do try to push things upstream, make sure that you abstract them as much as possible so that it's actually useful for everyone else using the tool. What's next for us? We currently have plans to experiment with some other backends, specifically so we can get some of that tagging metadata that I talked about earlier. We also have plans to try some more Grafana hacking. Specifically, we want to get some versioning for dashboards, and we want to be able to do sort of team groupings around dashboards so that a particular team can go in and have like their own view and they don't have to like query by the tag that's on the dashboard. We want to make it a more user-friendly experience for very large teams. So let's move on to our next monster, logging. So we're running a fairly standard elk stack. We store 2 weeks of data. Again, we found this to be fairly reasonable for most of the debugging purposes that people have. We index by day right now, and we're looking to start indexing by size to increase some of our throughput when we're writing. We have 450 nodes in our cluster. We store 250 terabytes of data. We have 140 billion documents, and we currently index 225,000 events per second to disk. And each of those indexes I mentioned is sharded across multiple nodes, and we again have a replication factor of 2. So some logging pricing. This is a little bit weirder to do estimates for because there's a bunch of different conventions. Generally, you're paying on the order of how many gigabytes you're storing per day instead of total, so that it varies. And the largest listed pricing volume I could find was for 100 gigabytes stored per day, which is almost 2 orders of magnitude off of our current daily storage of 16 terabytes. And again, with all of these things, these are like estimated pricing. As the volume goes up, usually you get more and more discounts, but we're just going to go with what's listed for now because that's what I could find. So the first, an anonymized offender, you're paying $50 per gigabyte. This is, again, monthly. $50 per gigabyte that you store daily. And this is for a license. You have to host it yourself. So yeah, you're basically paying for your own upkeep. Another one is going to be $150 per month per gigabyte that you store daily. They store it all for you. It's handled. And another is about 40 gigabytes per month that you store total. This is one of the few that basically gives you, here's how much data you're storing for the long term, and they just charge you per that. So again, if we assume a nice 50% discount for just the license, which is not this, we're at about $400,000 a month just for the license to run on top of the cost for having the hardware and labor ourselves. Or with our 16 terabytes stored daily, $150 per gig that we've stored daily with our nice discount, we're at $1.2 million per month for our logs. That's a lot of money. Again, Brian, so jealous. But here's what we decided to build instead with our handful of engineers. Again, this is fairly standard. All of our logs are submitted through, and from up here, these are just clients. Imagine this blows out into each of these. Each of these is a host. Basically, all logs are submitted through a local rsyslog client. They connect to the syncs, and I'll explain what a sync is in a second, via a long-lived TCP connection through the ELB, and they send all the logs using the REL protocol. We chose these syncs as an extra step where we use rsyslog kind of as like a back-off mechanism. Basically, if indexing slows down here for any reason, we don't want it to basically push back up the pipe and start affecting our clients, which is something that you need to keep in mind when you have all of your logs going to a single location. Originally, we also had queuing, which is these sync boxes, and the filtering mechanism in Logstash all on a single host. But we found that they're bound on completely different things, so separating them out made a lot of sense. Right now, we've separated out Logstash into its own auto-scaling group that's basically bound on CPU triggers, so Logstash is able to scale up when it needs to when it has more work to do. And the queues, if they exist, are not affected. Woo, zooming in. Basically, after Logstash, it goes to a bunch of client nodes, which then write to the data nodes. Again, writing first to the clients instead of the data nodes, just give the data nodes a little bit of a break. We have a bunch of read-only client nodes that we have as well, one of which currently has Kibana running on it for people that want to see the actual logs themselves and do searches. And then we have a pool that are queried by Grafana. again, for alerts, graphing, that sort of thing. And this thing that we've built in-house called Civ, which is kind of a replacement for ElastAlert. Civ is interesting in that it was built by one of our developer teams. Basically, they found that ElastAlert wasn't quite doing what they needed to do to see alerts for the web app itself. So they're like, we're going to build our own thing in true engineering style. But it's awesome, it works, and it's great. So lessons learned for logging. If you can structure it, do it. This is very similar to the metrics. We're talking about metadata. Parsing is not just expensive for the machine work for Logstash. It's also pretty expensive for engineering overhead for fighting with Grok. Like, how many of you have been like trying to figure out how to take this thing, you go to whatever that, I don't even know the website because it's bookmarked for me, because it's like, here, let's translate this. If you can structure it, do it. It'll make your life a lot better. Importance, similar to metrics, if you can understand what queries are being made and what log types are most important, it'll save you a lot of money and stress because you can figure out what logs you just don't need to keep around for as long or at all. And ABT, always be tuning. While you're tuning things, don't always trust what it says on the tin. While we were tuning parts of the stack, we found our syslog, Logstash plugins, and other things doing kind of funky things, and sometimes doing really funky things that they even explicitly said they would not do. So while tuning, don't be afraid to dive deep in the code if things look a little bit different from what you're expecting it to look like. As far as what's next on the horizon for some of the things we're building, we're currently playing with the idea of multiple clusters. We've trialed splitting out to multiple clusters that are fronted by tribe nodes. We might be switching to cross-cluster search nodes because tribe nodes might be getting deprecated. But ultimately, the idea is to isolate different log types and be able to better tune clusters based on the needs. Again, this is going back to, hey, maybe there's a particular log type that we want to have always available because our developers are looking at this like every few seconds to debug things, whereas like this like sad little log type that's looked at once can go live over here. We don't worry quite as much about like how fast it's being written to disk. Like, we just don't care. We also might play around with replacing our syslog at some point in time for the courier and queuing mechanism, but we don't know yet. We have lots of ideas. So let's go to our last monster, alerting. So some stats around this. We have 140,000 services that we check. We monitor 6.3 thousand hosts. And impressively, at least I think so, our largest check latency is about 3 seconds. We have some auto remediation defined for our alerts because, like Alice said, basically if it can't fix itself, if it can fix itself, we don't want to get paged about it. But we do still like having a record of those like blips that happen where they were fixed. With auto remediation, you really need to be important that you aren't just silently fixing a problem, because sometimes that just bites you in the ass when you discover, hey, this thing has been having a problem for a month, but it thought it was fixing itself. So auto remediate where you can, but also make sure to keep track of those remediations that are happening. I don't have pricing estimates for this next part. As far as I can tell, most folks kind of do their own monitoring systems internally and then just push out to like PagerDuty or VictorOps. So instead, I'm just going to jump straight into what we have. So we currently use Icinga. Seems like there's not quite a lot of Nagios love today, but I'm going to show some love. Basically, we have too many services for a single Icinga host, so instead we have a federated setup across a bunch of hosts. There's a one-to-one mapping between clients and Icinga backends. We use Chef internally for our config management. Basically, we use Chef attributes. Those build out active and passive checks for each backend based on attributes that are defined on the node. We're about to zoom in. I'll show you in advance from here. Woo! On the backend, Icinga hosts themselves, we're running a couple things. There's xinetd, which basically exposes this live status API to Thruk, which is back here, and I'll talk about in a second. Thruk is basically a catch-all to see all of the things. I'll explain that. It also runs Icinga, which issues active checks and basically processes the results of passive checks. Those passive checks are sent from the clients using this thing we have called NSCA wrapper. And they send to NSCA server on the Icinga backends themselves. And once all those things are processed, Thruk basically sits on top and visualizes the state of Icinga's service results across all of the backend hosts. We also have CloudWatch to watch some things for like ELB spillovers. We have Thousand Eyes, which monitors uptime from agents for things across the world for Slack, like Slack.com. Interestingly, it is also our monitor that watches the monitors. It's the thing that lets us know if Icinga is having issues and is down. And finally, all of these three things pipe into Slack or PagerDuty when there is an actual problem. So some lessons learned here. This is, again, fairly Icinga specific. But if you have a lot of hosts, active checks get very resource intensive. It's very, that's the first thing we had to basically cut out. We started a few years ago with a fairly healthy mix, and we've since moved to nearly 95% passive checks. That means that hosts are sort of checking themselves, trying to see what's up, and then going to Icinga and saying like, hey, I'm cool, or hey, I'm like pretty fucked up right now. Usability. Alerts need to be usable. This is, I assume, a theme that we will continue to see for the next few days. To make sure alerts in Slack make more sense for whoever gets paged, what we've done is make it so the Slack message can unfurl a Grafana graph where applicable. The titles have links to runbooks, which we have fairly rich runbooks that, again, have links to applicable graphs. Here's the things that you need to do to fix it. Here's who you can escalate to in the event of an emergency, what's happening, who's affected, do you need to update the site, those sorts of things. The most important thing for us with alerts, similar to logging and metrics, is making sure that whoever needs to can find their answer as fast as they possibly can. And similarly, we want to have making alerts be very, very easy and frictionless for developers. We've experimented with Grafana alerting. We're currently on Grafana 4. This way, developers can just make a graph, say, hey, I want to alert on this thing, and go from there. They don't need to worry about understanding Chef. They don't need to understand who to issue the query to. They just will have it happen. Not being able to do this in the past has kind of slowed us down, and so we're trying to speed that up. What's next? Icinga 2. It is the future. It requires us to make a bunch of changes to the infrastructure that we currently have. And while it's likely we're going to go down this route, basically we haven't done it because we've been following the old adage, don't fix what's not broken. Icinga has worked fairly well for us. Every now and again there's something that could be done better, but it's been a pretty good workhorse for us. So we haven't wanted to invest the time and effort to completely append it and just put a new thing in its place. And the last thing is that given that we have multiple systems that currently alert, it would be really nice to have a single unified interface. And actually, I can't remember who, there's the vendor earlier who was talking about that. I was like, tell me more. But basically, being able to summarize the state of all things, not having to know that you need to look in Throok or look in Thousand Eyes or look in CloudWatch would be really nice. Slack and PagerDuty let us know when things are broken and aggregate across those, but it would be nice to just be able to say, what is the state of this cluster across the board right now? So the question that I think pretty much everybody wants to know, the question that Missy Elliott likes to ask, is it worth it? Do I think it's been worth it? So as mentioned before, we started with very few and we're currently up to 5 full-time engineers. And we're all working on a combination of these systems and the data warehouse infra and our ops stuff at various points in time. But money-wise, hosting and running these solutions ourselves versus the hypothetical vendor solutions is saving us more than $1 million a month, which is pretty good in my opinion. It also doesn't even take into account the cost of egress, of data egress if we sent our logs or metrics to an external vendor, since we're doing everything in Amazon right now. So that's even more cost that I could probably calculate. But yeah, saving money. Money's awesome. Also running these solutions ourselves has allowed us to customize flexibly as strange needs or problems have come up. If a particular concept isn't available for a vendor solution, you kind of have to wait and hope that it comes on their roadmap. Running it ourselves, we can just build these concepts into the tools ourselves, and we don't end up being that big bully who's like, we're paying you this much money, build it for us right now. That's no fun. I don't want to take over someone's company just because we have a lot of data. Maybe you want to, that's cool, do your thing, but it's not what we want to do. The flip side, these systems do require a fair investment of time from our team, particularly making sure that they are stable, reliable, and performant at all times. And that's a trade-off that's really hard to evaluate up front when we're making all of these considerations, and it's something that you'll need to keep in mind too if you're doing something similar. So at the end of the day, the only constants in life are life, death, taxes, and the fact that if you build a storage system for metrics, your developers will basically be calling a wrapper as fast as they possibly can to store things in it. You can try to calculate what your inputs are going to be using things like number of hosts, number of engineers, number of lines of code, number of users you expect. But the only thing that is guaranteed is that those numbers are going to keep growing and in ways that are hard to estimate. I was watching backstage, I think I saw Roy's graph of where they just like grew by an order of magnitude of the number of metrics they have, and it's like, it's kind of hard to predict. Like, you know that you're going to be growing, but like, how fast? Who can say? You can't, literally. The main thing you need to figure out is what your priorities are. Before you try to fit solutions in place, you need to decide how much you're willing to invest in each of those 3 areas that I mentioned earlier. For us, we value flexibility, money, and time spent, probably in that order. For you, it may be very different. So I think I'm just at time and just in time for lunch. If you have any questions, if you want to commiserate about any of these technologies in particular, if you want to slay some of these beasts with us in the technical, D&D, or Beyonce sense, our whole team is here this week, minus Tom. Shout out to Tom in Australia. Basically, I want to thank all of you for your time. Thanks for watching, and hope you have a good rest of the conference.